Hello and welcome to this video tutorial. Today we're going to look at Unit 5, Lesson 1, Slope and Parallelism. Keep in mind that there is a geometry component to this lesson, but it still also involves the concept of slope. Slope meaning rise over run. So be prepared to use slope as a concept and be prepared to do slope calculations using our slope formula, y2 minus y1 over x2 minus x1. Also, of course, remember to pause or rewind the video as needed. Okay, let's begin. So, graphically determine the slopes of the line segments of triangle ACD as shown below. Write your final slopes in the simplest form. Okay, so what I'm going to do is I'm going to show you AD. So this was line segment AD, and you draw the little line over the two letters that are at the end points of the segment. So AD, that's this line segment here. And there's two ways we can find this slope. I'm going to show you both ways, and then I'm going to show you for CD and AC, segment CD and segment AC, kind of what I feel to be a more efficient and faster way. And then from that point, you choose what works best for you, okay? So for AD, there's two ways we could do this. One way is to first list all the coordinate points for ACD. So the coordinate point for point A is -2, comma, -2, comma, -7. Okay. For D, for point D, that point is all the way over here at x equals 9 and y equals 2. All right, and then point C up here is all the way over here to -6 and all the way up here to 7. So -6, comma, 7. So one way we can do, find the slope for this segment here, I'm going to color it yellow, AD, is to do your coordinate points. So A is -2, -7. That's point A, and then point D is 9, comma 2, 9, 2. So one way we could do this is by using our slope equation. So x1, y1, x2, y2, and simply plug that into your slope formula. So y2 minus y1 over x2 minus x1, which would be y2, that's 2, minus y1, that's a -7, over x2, that's 9, minus x1, that's a -2. Now remember, when you see minus a minus, that means plus. So 2 plus 7 would be 9. And down here, that's a plus as well. 9 plus 2 would be 11. And so our slope is 9 over 11. Okay, so we can use the slope equation between coordinate points to always find a slope no matter what. So that's one way to do it. The other way to do it is by simply using slope equals rise over run. Okay, and here's what I mean by that. You're literally going to go from one point to another point. So if I go from A to D, I have to rise 1, 2, 3, 4, 5, 6, 7, 8, 9. I got a rise of 9. And a run, I'm going to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have a run of 11. Okay, and so you can see I get the same slope, 9 over 11. I tend to think this way is way more efficient and faster when I have a graph. So I tend to usually use just a simple rise over run method of getting my slope. And that's the way I'm going to use it for the rest of this lesson. But do keep in mind, you can calculate the slope using coordinate points if you so choose. Okay, so now how do I find the slope for line segment CD? That would be this segment here. Okay, now I'm going to erase this work here. Now to go from C to D, notice that that blue line is going downward, not upward. So to go from point C to point D, I have to go down 1, 2, 3, 4, 5. I'm going down 5. That's negative 5. Then I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so my slope for CD is going to be negative 5 over 15. Now reduce this, okay, and we can reduce this by dividing by the largest number. What's the largest number that divides into 5 and 15? Well, that would be a 5. So 5 goes into 5 one time, so it's negative 1, over 5 goes into 15 3 times, we get a slope of negative 1/3. Okay, and then finally, I'm going to highlight this one in orange, AC. Okay, now keep in mind, AC is not going to go up in that direction. It's actually going to go from C to A downward, okay, as we take a look at that. So I'm going to erase this work here. So now I've got to go from C to A. So to get that, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the rise is negative 14. And the run is going to be 1, 2, 3, 4. Run's going to be 4. So I end up with a slope of negative 14 over 4. Now keep in mind, I have to reduce this to lowest terms. So the largest number that divides into these both would be 2. And 2 goes into 14 7 times, so that's negative 7. And 2 goes into 4 2 times, that would be 2. So I get negative 7 halves would be my slope. Number 2, on the diagram below, draw a line that passes through point C and is parallel to AB. Okay, so what does it mean? So how do you have a line parallel? It has to have the same slope. So first, let's find the slope of line segment AB. Okay, so the slope of line segment AB is going to be, I'm going to use my rise over run. Okay, let's figure it out right now. We're going to go down 1, 2, 3, 4, 5, 6, 7, 8. Down 8. The rise is negative 8. And a run of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Run of 12. So I have a rise of negative 8, run of 12. I need to divide the largest number into both of these. That would be 4. So that I could reduce this. And I get negative 2/3. Okay, that's my slope. So now the new line segment has to have the same slope. And here's an easy way to do it. Start at point C and go down 2 over 3. And then draw a line from there. So start at point C, go down 2 over 3, okay, and make a point right there. And you draw a line through that. and you'll see that those two lines are exactly parallel. Okay, number 3. If the line you drew in number 2 was extended, would it eventually pass through the point E, which is 8, negative 8? Explain how you determine your answer. Well, it would only pass if the slope between 18 and negative 8, that's point E, and point C, which you can see is the 0.32. So it would only pass if the slope between those points is also negative 2/3. So if I get the exact same slope through that, then I know the line will extend through. So I'm going to find that. I'm going to find that right now. I'm going to find the slope. So x1, y1, x2, y2, plug it into your slope equation. Okay, y2, that's 2 minus, that's supposed to say y1, sorry, y1, which is negative 8, over x2, which is 3 minus 18. So 2 minus a minus 8 is plus, so that's 10, over 3 minus 18, which is negative 15. Now, you could write this any way you want. So it's negative something. Now, what is that negative something? Well, I got to reduce this. The largest number that goes into 10 and 15 without a remainder would be 5. So we're going to divide 5 into both. And I get 10 goes into 5, or 5 goes into 10, excuse me, 2 times. And 5 goes into negative 15 3 times. So you can see we get the same slope. So yes, the extended line will pass through point E, which is 18, negative 8. Okay, let's scroll on to number 4. So given the 4 points, A, B, C, and D, are A, B, and CD parallel? Well, here's what you're going to find. We're going to find the slope between AB, then we're going to find the slope between CD. They are only parallel if they have the same slope. That's what we're going to find out right now. We're going to calculate the slope for both those pairs. So x1, y1, x2, y2, and then do the same thing over here. x1, y1, x2, y2. Okay, so here we go. For segment AB, the slope, remember the slope equation, right, is y2 minus y1 over x2 minus x1. So we are going 13, that's y2, minus 5, that's y1, over x2, which is 1, minus x1, which is negative 3. All right, subtracting those, we get 13 minus 5 is 8, over 1 minus minus 3 is 1 plus 3, or 4, and we get a slope of 2. Okay, for CD, we're going to go y2, that's 5, minus y1, that's 2, over x2, that's 10, minus x1, that's 4. So I get 5 minus 2 is 3, over 6 minus 4 is, 10 minus 4, 6. Reducing this, right, I'm dividing both by 3, right, and you can see I get 1/2. Well, they are not the same slope. Therefore, they are not parallel. Number 5, given 4 points, E, F, G, and H, is EF parallel to GH? Again, we're going to find the slope for EF. We're going to find the slope for GH. If they are the same slope, then they are parallel. Let's find out. So EF, segment, line segment EF, we're going to find the slope. Okay, so we're using our slope equation right here. So so I'm going to go x1, y1 over x2, y2. Okay, so I'm going to go y2, that's 1, minus y1, that's 5, over x2, that's 7, minus x1, that's 2. So I get, let's see, 1 minus 5 is -4, over 7 minus 2 is 5. So I get a slope of -4/5. Okay, now if I go GH, line segment GH, okay, same thing, x1, y1, x2, y2. Okay, y2 is going to be 5, minus y1, which is a -3, over x2, which is -8, minus x1, which is 2. So on top, I have minus and minus is plus, so I get 5 plus 3 is 8, over -8 minus 2 is more negative, which would be -10. So this needs to reduce. The largest number that goes into both would be 2. So if I reduce this, I will get -4/5. And you can see, ladies and gentlemen, the slopes are the same. So since the slope of line segment EF is the same as the slope of line segment GH, then line segment EF is parallel to line segment GH. Okay, and in our final question, it says, given quadrilateral shown ABCD, answer the following questions. Determine the slopes of all 4 sides, either algebraically or graphically. Label all slopes. So I'm going to color code the line segments. So we have line segment AB in yellow. Let's find its slope. I'm going to use the rise over run model since I have a graph. So go from that point to that point, which means I'm going to go up 2, that's a rise of 2, and a run of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 over 10. Which needs to be divided by 2, and we get 1/5. Okay, so our first step is just find the slopes of all 4 sides. Okay, so now I'm going to go to AD. Okay, so for AD, I'm going to go from A all the way up to D. So I'm going to go a rise of 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to run of 1, 2. So rise of 8, run of 2. Which would be a slope of 4. Okay. All right, now I'm going to go from D to C, but you always label it in order of letters. So the line segment from D to C is going to be written as CD, right? Because C comes first alphabetically. So our slope for that one, okay, from D to C, is we're going to go up 2 and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up 2 over 10. Again, if I divide both sides, I can see I have a slope of 1/5. I'll do that one in gray. Okay, and finally, we got to find the slope of line segment BC. Okay, so for that one, we're going to go from B all the way up to C. So we're going 1, 2, 3, 4, 5, 6, 7, 8 up, and then 2 over. 8 up and 2 over. 8 up and 2 over gives you a slope of 4. I'll label that one in green. And so those are our four slopes. So state all the parallel sides. Well, parallel sides have the same slope. So the sides that have the same slopes are parallel to each other. So that means AB with a slope of 1/5 has to be parallel to CD, line segment CD, because you can see they have the same slopes. It also means AD with a slope of 4 is parallel to BC, line segment BC, also with a slope of 4. What type of figure does this represent? Well, this is a parallelogram. Okay, and the reason why it is because both pairs of opposite sides are parallel, right? AB is parallel to CD, and AD is parallel to BC. Again, remember to pause or rewind the video as you need to. I hope you found this to be helpful. Thank you, and see you next time.